Electric vehicles are at a major turning point in history. We're seeing a lot more adoption of electric vehicles, more being sold by dealerships, new and used. But behind the scenes, there's a lot more going on with EVs than just what you see in the car market. One of the things that we take for granted with traditional gasoline vehicles and diesel vehicles, but internal combustion engine type automobiles, is that the engineering and technology for those vehicles have evolved for over 100 years. These vehicles are mass produced starting in the early 1900s, 1908. By the 1920s, there were dozens and dozens of manufacturers of these vehicles. And over the last 100 years, they have gone through major evolutions and upgraded technologies and made engines better, introduced things like turbochargers and automatic transmissions. It's taken 100 years. Now, electric vehicles are at the early stages of that technology. Imagine if you compared a gasoline vehicle from today to a 1900-something Model T Ford. It'd be like night and day. Other than 4 tires and an engine, there would not be much similarity. The problem is electric vehicles need to ramp up and have a adoption curve much quicker. Because of that, engineers are very quickly changing the way that they do research for electric vehicles. And this is an excellent 10-page document, came from an engineering firm that talks about what's going on behind the scenes for electric vehicles. So let's take a look at a couple key points. And this affects you as a consumer, so you know what's going on in the marketplace and with your vehicle as you're purchasing a new or used electric vehicle. First of all, in testing powertrains, there's a lot of things that go into it. You have to look at the risks. Is there safety issues? Proper engineering and administrative protocols have to take into account heat, radiation, noise, electric shock. Think about that electric shock. You have hundreds of volt power plants inside your vehicle, and in the past, that didn't have to be considered in a motor vehicle. Sure, you have 110 or 220 volt wires in your house, but they're hidden behind walls, and there's a lot of safety protocols that have gone into that. It's not very frequent that you're digging into your house. Well, cars get crashed all the time. What happens if you crash a car and a 200 volt wire touches a piece of metal because it's crunched? Does that electrify your whole car? You're going to get electrocuted. You also have to take into account the market. If you take too long for engineering, you'll be late to the market. That's an economic fact. Money. Certainly, you have to capitalize money so that if you develop all this technology but you're not able to sell enough cars to make it worthwhile, then the engineering itself goes to waste. And also, the longevity. You have to be able to warranty this to consumers. If consumers are buying a new type of vehicle and they find out very quickly that they're not reliable or they have higher maintenance or repair costs, that's going to really put a crimp into the adoption of these vehicles. And this is what we started talking about. The biggest risk is unfamiliarity. Vehicles may not look very different on the outside, but they're completely different on the inside, meaning that if you look at an electric vehicle, an EV, parked right next to a gasoline vehicle, for the most part, they look the same. Some electric vehicles don't have grills because you don't need air to cool off an engine, but other than that, they're very, very similar. The styling might be different to reflect that it's more technologically advanced, but the way the car operates is completely different. Then you also have to consider the environmental testing, not environmental in terms of green energy, but in terms of the vehicle lasting in the environment. Without proper testing, you may find that all weather operation will be degraded. So if you have a car that can't operate when it's 100 degrees out or when it's 0 degrees out, you're going to lose a lot of market share because many vehicles are operated outside of the 40 to 70 degree sweet spot. Below freezing, high temperatures, and that can affect batteries and motors. Here's another big one, noise and vibration testing. Look, back in the 60s and 70s, vehicles went through a painful kind of growth curve where cars were basically falling apart because you went over bumps and things shook loose. Brackets broke. There were rattles. It was notorious for vehicles in 60s and 70s to have a lot of rattles and noise coming from places you couldn't find, under the seats, behind dashboards. And so doing these new testing operations on electric vehicles is important, because a vehicle battery is an electronic device. It may be very sensitive to vibration, may be very delicate and fragile. And if you don't build a vehicle that can take bumps, you go over a pothole, you go down a bumpy road, then if the battery can't survive that impact, then the vehicle's no good. It's one thing to have a seatbelt rattling in your back seat. You can still drive the car. It's another thing to have a battery become non-functional because the vibration either damage it internally, or some of the leads, or over time degrades the charging and discharging operation of the battery. What about radiation? The electromagnetic spectrum is something you don't think about with gasoline vehicles. Vehicles are subjected to all kinds of radiation on a daily basis, from the sun, from motors, from electronics. Think about in the old days when you would have a radio and you put it too close to your microwave or a TV. You would get static, right? Batteries are electronic devices that if they're too close to other electrical output sources, you can have disruptions in the electronic field. What if you drive too close to a power plant? Is that going to mess up your battery on your electric vehicle? These are things they have to test. For gasoline vehicles, all of these problems have been solved over many, many years. We're looking at adopting a completely new type of vehicle basically in a decade. Most experts want to switch over everything from gas to electric between now and roughly 2032. So less than 10 years, or about 10 years. The entire testing regimen of electric vehicles has to be done in 10 years, not 100 years. Certainly, we have more intellectual knowledge and engineering knowledge to do this. We won't take 100 years like we did with gasoline vehicles. But unless we take away some of these suggestions and use them to develop electric vehicles kind of more thoughtfully, it may turn into a big crash and burn if the vehicles aren't ready for prime time and they're not up to snuff for the vast majority of consumers to use them on a regular basis.